Have you ever stopped to think about how your microwave just knows when to stop? Or how your car's anti-lock brakes can react way faster than you ever could? It turns out there's this invisible intelligence packed into almost everything we use, these little hidden brains. Today, we're going to pull back the curtain and dive deep into these tiny technological marvels. Right? We throw around the word smart for everything now. Smartwatches, smart TVs, you name it. But what does that really mean? What actually makes a device smart? Is it just a miniature version of the computer sitting on your desk? Well, the answer is sort of, but it's also way more interesting than that.
And when I say they're everywhere, I mean they are everywhere. We're talking about the appliances in your kitchen, the cell phone you're holding, the printer in your office, and these super complex systems running under the hood of your car. They are truly the unsung heroes of our modern lives, just quietly doing their jobs.
Okay, so let's get into it. It's time to reveal the core technology that makes our world tick. And it all boils down to this one incredibly powerful concept: an entire computer, all on a single chip. And that, my friends, brings us to the star of the show, the microcontroller. You can see the official definition here. It's a complete computer system. That means it's got the processor, the memory, and all the tools it needs to talk to the outside world, all fabricated on one tiny piece of silicon. This is the hidden brain we've been hunting for. And this diagram here, it shows you exactly what that means. You got the CPU, the central processing unit, which is the core brain, right? But look what else is on there. You've got memory, both ROM for permanent instructions and RAM for temporary stuff. And you've got all the input-output, or I/O, that lets it interact with other parts. It's a totally self-contained little powerhouse. And that's the most important thing to get. A microcontroller isn't just the brain. It's the brain, the arms, the legs. It is the entire operation. It has everything it needs to do its one specific job, all packed into one tidy, efficient component. And that's what makes it so different from what we usually think of as a computer. So, to really appreciate the genius of the microcontroller, we have to compare it to its much more famous cousin, the microprocessor. This is where we get that big aha moment. This image just lays it out so clearly. On the left, you've got a system built around a microprocessor. That chip is just the CPU. To do anything, it needs a whole support team of other separate chips for memory, for input/output, for timing, the whole shebang. But then look to the right. The microcontroller, the whole team is already on the chip. It's a one-man band. And this table really drills down into that difference. A microprocessor system, like what's in your PC, needs all that extra hardware, which makes it super flexible and powerful for general stuff. You know, like browsing the web or playing a game. A microcontroller is the exact opposite. Because everything's built in, it's way less flexible. But that's its superpower. It's designed to do one specific job and do it cheaply and efficiently. Okay, I know this has all been a little bit abstract so far, so let's make it concrete. Let's get our hands dirty and meet a true legend in this field. It's time to meet the one, the only, the 8051. You have to go all the way back to 1981. This is when Intel introduced this little 8-bit microcontroller. It was so complete, so self-sufficient for its time, that it was literally known as a system on a chip. This thing was a game changer. And here it is, the blue point. Just look at this diagram for a second. Everything we've been talking about, it's all laid out right here. You can literally point to the CPU. There's the ROM and RAM for memory. And you can see the timers, a serial port, and those all-important I/O ports. It's all there, beautifully integrated. So let's talk specs. The original 8051 had 4 kilobytes of storage for its main program, and get this, 128 times bytes of RAM. Not gigabytes, not megabytes, bytes. It sounds like nothing to us today, but for controlling a specific device, it was a powerhouse. Now, I've said I/O ports a few times. What are they? The best way to think about them is as the chip's senses and its voice. They are the physical metal pins that connect the chip to the rest of the device. This is how the microcontroller can read that a button has been pressed, or send a signal to light up an LED, or tell a motor to start spinning. It's the bridge between the digital brain and the physical world. So now that we know what they are and how they work, let's zoom back out. Let's really take a look at the incredible and sometimes pretty surprising impact these tiny computers have on our daily lives. I mean, just take a look at this list. Okay, anti-lock brakes, engine controls, that makes sense, right? High-tech car stuff. But it just keeps going. Color copiers, lawn sprinklers, even fish finders, they are in absolutely everything, performing these critical little jobs completely hidden from view.
And what about the legacy of that classic 8051 chip we just looked at? Well, its design was so good, so efficient, so timeless, that today over 20 different independent manufacturers are still producing new and improved versions of it. Now that is a design that has stood the test of time. Which really brings us to a final thought. We've seen that these hidden brands are already everywhere. But here's the thing. They are constantly getting smaller, cheaper, and way, way more powerful. So the real question is, what's next? What everyday object that you think of as totally normal today will secretly have a smart brain inside it tomorrow? Your coffee mug? Your running shoes? The possibilities are absolutely endless.